So, good day, grade 8 max size students. For our lesson for today, we're going to be discussing about triangle inequality theorem. So, there are a lot of things. There are a lot of things that we see that have triangles on them on our surroundings, most of which are constructed by men, okay, and also most of those structures, not all of them have congruent sides or have the same sides. So at a bridge, most of them you're gonna see some triangles there may have isosceles shaped or they have congruent sides, but there are also triangles there that do not have the same side measurements or the same angle measurements. So that's why it's very important to study triangle inequality and also understand the underlying concepts that surround these different types of triangles. So before we get into our lesson, let's try to answer some of these problems. Okay, so for the first one, Thea, Rhea, and Alyssa were given different pieces of string each. They were told to create a triangle and each cut off a side of the string as follows. So for Thea, it's 6, 4, 10. Yes, so that's 6, 4, 10. And then for Rhea, that's 12, 15, 26. And then we have for Alyssa, that's 6, 9, and 12. Okay, so who among the three, okay, would create a triangle out of those strings that they were given? Okay, so in order to create a triangle, guys, okay, so the two shorter sides here, the two shorter sides should be greater than the third side. Okay, so for the first case, we have here 6 plus 4, and that's equal to 10, and the third side is 10. So 10 is not greater than 10, it's equal to 10. So therefore, Thea will not be making a triangle with her strings. How about Rhea? Okay, so that's 12 and 15. If you add that, that's 27, right? And 27 is indeed greater than 26. Okay, so therefore, Rhea could make a string, could make a triangle for this, for her strings. And then we have Alyssa. Okay, so for Alyssa, we have here 6. Okay, 6 plus 9. Okay, so that's 15, which is indeed greater than 12. So therefore, what can be the answer for this question? Okay, so it's letter C. Alyssa and Rhea can create a triangle out of their strings. Okay, so second one, which the lengths of segments DC and RC in triangle RDC. Okay, so let's try to draw that. Okay, so we have here triangle RDC are 8 millimeters for DC and 11 millimeters for RC. Okay, so there you go. What is the range of the values for segment DR? Okay, so what's the range of the values for this segment right here? Okay, so therefore we know that the values of DR should be greater than 19, right? Okay, so it should be greater than 19 for this one. DR should be greater than 19. For also, it should be greater than 3. Okay, so there you go. Okay, and then for the next problem, okay, in triangle art, which side is the shortest given that the measurement of angle A is equal to 40 degrees and the measurement of angle T is equal to 75 degrees? If we're gonna draw triangle art, okay, so we have here ART. Okay, so which side is the shortest if angle A is 40 degrees and angle T is equal to 75 degrees? So how will we solve for the value of angle R? We simply add the measurement of angle A and the measurement of angle T. And 40 plus 75, that's just gonna give us around, okay, that's gonna give us 115. And 180, okay, 180 degrees minus 115 degrees, that should give us 65 degrees for the measurement of angle R. So therefore, if the measurement of angle R is 65 degrees, which of these three sides have the shortest side? As we're going to see, we have to follow one of the theorems about the lowest angle or the smallest angle having the smallest opposite side. So since 40 degrees is the smallest angle here in this triangle, so therefore RT, okay, it makes sense that RT should be R, shortest side for this given triangle right here. Okay, let's try this one. In triangle FOR, we have, let's draw first triangle FOR. So there we go. So we have here OF is equal to 9, FR is equal to 12, and RO is equal to 18. So we have to arrange the angles from ascending order. So what do we mean by ascending? Okay, so we start first with the least or the smallest angle, and then we go to the largest angle. Okay, so we have here the side measurements. So we have here for FO, that's 9, for FR, that's 12, and for OR, that's 18. So if we're going to notice their angles, the first angle that should be the smallest should be angle R, and then the next one should be angle O, and then the next one should be angle F. Okay, so there you go. So for this problem, okay, so the smallest angle should be angle R, the next one is angle O, and then third one, the largest angle, should be angle F for this one. So our answer here, okay, is angle R, O, and then F. Okay, and then lastly for this one, given triangle LEA, okay, so let's try to draw that. Okay, so we have triangle LEA, okay, and the measurement of angle L is equal to y plus 10 degrees, and the measurement of angle E is equal to 2y plus 20 degrees, and the measurement of angle A is equal to 5y plus 18 degrees. So we have to list, okay, the angles, okay, from least to greatest for this problem. Okay, so for this problem, they're asking for the angles. Okay, so we have to list the angles from least to greatest. So how are we going to do that for this problem? Okay, so we can see here that we have here the y. Okay, let's look at the y variable here. Okay, so for y here, we can start with angle L. Okay, then we go to angle E, then we go to angle A for this one. So therefore, okay, our answer here should be letter C for this problem. Okay, so now let's go to the different properties of inequality. So you've encountered these properties when you were in grade 7, most likely. But let's try to review some of them. Okay, so the first one is the trichotomy property. So only one of these three conditions should be true. It should be A. It should be A is less than B, A is equal to B, or A is greater than B. So they can't be true. The three of them cannot be true all at the same time. So that's the trichotomy property of inequality. And then we have the addition property of inequality. It says here if A is greater than B, then if we add a constant, let's say that's a C, or let's say it's a number 5, then therefore A plus C is greater than B plus C, because your presupposition, what you suppose, A is greater than B. Okay, so if that's true, so therefore if you add a constant to both sides, so therefore the thing that you added it would still not affect the validity of your first statement. So therefore A plus C is greater than B plus C. And then we have the multiplication property of inequality. If A is greater than B and D is greater than 0, so therefore A times D is greater than B times D. So it's also the same with addition property of inequality, but for, of course, multiplication, you're going to multiply the variables or the constants that you have. And the inverse of that would be that's less than BD. Okay, so let's try an example here for multiplication property of inequality. Okay, let's say for example that we have 4, okay, is greater than 2. Okay, so therefore, and we have D here, let's say for example D is equal to 3. 3 is greater than 0. So therefore it says here that 4 times 3 should be greater than 2 times 3. And indeed that's correct. So 12 is greater than 6. Okay, if we try the second statement, so again, let's keep those conditions true for the first one. So we have here 4 is greater than 2, and then for the second supposition, we have D is less than 0. So therefore D should be a negative number. Let's say it's a -1. So therefore 0 is indeed greater than -1, or -1 is less than 0. Okay, so if we're going to multiply that, okay, so therefore that's going to give us 4 times -1, right? Okay, so it's going to give us 4 times -1. Okay, so therefore BD is going to be greater than AD here. So that's going to be 2 times -1. And indeed, if we solve that, it's going to give us -4, okay, is less than -2. Or -2 is greater than -4. And then we have the transitive property of inequality. So it says here, if A is greater than B and B is greater than C, therefore A must be greater than C. It also works the other way around. If B is greater than A, or A is less than B, and if B is less than C, therefore A is going to be less than C for that one. And then we have here the definition for greater than or less than for segments. Okay, so we have these specific segments. If you're going to notice, the pattern still runs the same. For this one, we've only named here we've only named our geometric figures as segments. Okay, and then for this one, we have here angles, and then we just named our geometric figures here as angles. So they're both the same, both of which are still the same for these conditions. So let's go now to the theorems. Okay, theorems for inequalities of triangles. Okay, so for this activity, we're going to be manipulating certain triangles from a website. So if you guys know GeoGebra, okay, so we're going, you've been using that a lot. We've been using that a lot during our class discussions. Okay, so for the Hinge Theorem, what do you notice, guys, with these two triangles on the screen? So we have here a smaller triangle, so that's triangle ABC, and then we have a bigger triangle, so that's triangle DEF. Okay, so the first thing that we're going to notice is that both of these triangles have congruent sides. AC is congruent to DF. Okay, the first side of the first triangle is congruent to the first side of the second triangle. So the same as with their second side. So AB is congruent to DE. But what you're going to notice, guys, is the included angle, the angle between those two congruent sides, they are different. Okay, so what does the Hinge theorem tell us? So what goes around here, if you're going to notice the angle with the smaller of the two triangles, the smaller angle of the two triangles is of course going to give you a much smaller side as compared to the triangle with an angle that has the bigger angle. So it's gonna give you a much bigger angle as compared to the first triangle. So if we try to manipulate this, okay, so what may be your conclusions? Okay, so you can write that on the comment section. Okay, so there you go. If you see here, if we try to manipulate these sides, okay, the theorem still runs true. So that's the Hinge theorem. Okay, if you see a door hinge, okay, so that's where the theorem's name comes from. So from the door hinge. Okay, door hinge, if you like manipulate this, and just imagine this is a door. Okay, a door that you come through, and the angles here that you see, if you're going to compare them, there's going to be one smaller angle, and there's going to be another bigger angle for this one. Okay, that's for the Hinge theorem. Okay, so let's go to our main topic. Okay, so the triangle inequality theorem. So in any triangle, the sum of the length of any two of its sides is greater than the length of its third side. We already covered this. We already covered this on our first part of the lesson. So we have here side A. If we try to observe here, we have your side A and then side D. If we add both of those sides, okay, it should be greater than C. Yeah, so that's one possibility. That's one of the possibilities of the set of measurements that we have here. And then we have here side A and side C. If we add these two sides, okay, so it should be greater than the third side that was left, which was side D. And then lastly, we have side D plus side C. If we add those two shorter sides, it should be greater than side A. So what we're seeing here in the triangle inequality theorem, so the shorter sides generalizing the idea, so the shorter side should always be greater than the third side. So you cannot create a triangle wherein the two shorter sides are equal or less than the third side. You will not create a triangle. If we As you have seen also from our previous exercises a while ago, the sum of the two shorter sides should always be greater than the third side.